Alright guys, how you doing? Today we're going to be talking about surface area. We're going to be covering examples of how to find surface area when it comes to prisms and cylinders. Hopefully you've already watched the volume of surface area and prisms video, so you already have an idea of what prisms are, what they look like. Same goes for cylinders. And so everything we're dealing with does start us out in 3D as a three-dimensional figure. Everything is in 3D. But today, because we're going to be dealing with surface area, it's important for you to understand what that means. One word in there that you should recognize already is area. And so finding area for different shapes, for example, finding the area of a rectangle or a square, also knowing the formula and how to find area of a triangle, of maybe a polygon such as a pentagon or a hexagon, heptagon. Also finding the area of a circle, which you will see in cylinders. But when you're finding total surface area, keyword here, surface, it's you essentially taking a prism like this, a 3D figure, and breaking it up, or like kind of unboxing, flattening out the entire thing, so you have flat surfaces of every piece, of every face, every side that exists on it. So we're gonna kind of go over how we can do that, and then we'll focus on finding the area. But the first step for surface area is understanding how to break it up into all the surfaces and the faces. And so maybe an example that I want to try first is maybe the one right over here. So let's go ahead and look at this rectangular prism here. And so first step I said is to break it down. So what I'm going to do is I'm going to go ahead and highlight kind of matching sides. For example, maybe I want to let's start with the bases of this. Maybe that's easier first. So we have this bottom piece right here, and we also have the top here. Okay, those are two faces, it's the two bases. And what I'm going to do is I'm going to bring them over here, and I'm going to draw them flat as a surface. So I'll keep it green. So I have a shape that's like this, right? And just to mention, right, these are identical. So I'm going to take this and I'm going to double it. So I have two of them, and I'm also going to bring their lengths and widths with them. So it looks like this side is 12, this is 9. That would be the same case for down here. What I'm highlighting, they're both 12. What I'm now highlighting is also 9. So I'm going to go ahead and write 9 here, 12, 9, 12. Okay, I'm not going to go into finding area yet. I'm going to go ahead and maybe use a different highlighter now and get some more surfaces from this entire prism. So far, just the bottom and the top. Why don't we go ahead and focus on these sides right here? So let me go ahead and use maybe let's do purple. So this left side that I'm highlighting currently, and I'm going to take this far right side right here and highlight that as well. There we go, that looks good. So I'm going to use a purple color, and I'm going to draw both of those here. So I'm going to take this one here. They are identical. I'm going to go ahead and double that up. Okay. And then I have to pay attention to what those dimensions were that they gave me, right? So it looks like the height is 12. So 12 and 12. And then it looks like the width, what is that matching here? Looks like it's also 12, right? So notice this 12 is the same as this 12, as this one and this one. So we got 12 on both. So it doesn't really look that way the way I drew it, but it is. Okay, so far out of this, we've pulled out 1, 2, 3, 4 faces, and then I have 2 more to pull out. And so because there's a lot of highlighting going on here, I will use a different color. I'm gonna erase these, okay? You already kept track of it earlier, but this is to show you the very last one that I'm going to take out, which maybe I'll use red as the highlighter. I'm going to pull out the This is the very back face. And I'm going to pull out the very front face. Okay, they overlap a little bit. I want you to notice that. Okay, so the front and the back. And so I'll get a red marker for that. There's a red one. Here's a red one. Maybe I'll draw them over here. And then identical, the front and the back. And now I have to pay attention to the dimensions, right? So the height for both of these, right? I'll highlight everything that's the height here. Looks like to be 12. So 12 here and 12 there. And then the width all over is 9. So 9 and 9. Cool. All right, so what I just did in a sense is, you can call it the net, but it's also just me pulling out the flat surfaces, okay? Different from volume, right? When we talked about volume, it was about filling up this 3D box, but what we've just done is taken this 3D box and flattened it all out into its 6 faces, 6 bases, 6 surfaces. And so now that we've done that, it's a good thing to practice doing this. Instead of just trying to visualize it all here without doing the work of drawing, it can get a little confusing. So I like to do it this way. Our next step is now to find the area part, right? Surface, we did that. We pulled out all the surfaces and now we just find area. And what's nice about this kind of prism is that they're all either rectangles or they're squares. And we know that to find the area of something like that, all we do is take the length times the width and multiply it. So I'm gonna head and start with those green boxes at the top first. So 12 times 9. So the area here is 108. And because, remember, these are identical, the pairs that I drew together, because this is 108, I know this is also 108. And I'm circling it because I know that's the area that I have to keep track of. And now I'm going to move down to the 12 by 12 rectangle. And so this is 144 and this is 144. Just finding areas here. And then I'm going to move to the 12 by 9, which will give us 108 and 108. Okay, from here, you might think you're done. You're like, oh, well, I found the area of all the surfaces. But when you are asked for the surface area of the figure, you are asked for the surface area of the entire thing. But this is all the entire thing. So what you're going to do is take all the areas of the surfaces you found now, and you will add them up. And so I'm going to do that on my calculator. I'm going to make a little spot here and say SA, which will stand for surface area. And what I'm doing is, like I said, I'm adding up all these areas on my calculator, okay? So I'll type it out and you'll hear me say it. So 108 plus 108 plus 144 plus 144 plus 108 plus 108. Cool, we did top, bottom, left side, right side, front, and back. Cool, all right. So our total surface area, when you add those up, should be 720. That is the total surface area, as in like the area of this, 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 and this, all added up. 720. Last thing we need to keep in mind is the units. It is in inches. And because keyword area, when we work with area, this is all in square units, so we make it squared. All right, so I hope that's helpful for how we deal with rectangular prisms. I'm gonna go ahead and move on now to a triangular prism. And I'm gonna do the same thing I did here, which is kind of like to draw the net or to draw out the surfaces. So why don't we look at, let's look at this one right here, number 4. So I'm gonna go through the same process, right? I'm gonna go ahead and grab my little highlighter, and I wanna start with, let's see what I wanna start with. Start with the bottom and the top. That's always kind of nice and easy, the bases of the prism. I'm not highlighting the best right now, but not a big deal. I'm just showing you the 2 identical bases there. Cool, all right. And what I'm gonna do is I'm gonna draw them out. It won't be pretty, but it'll work. Okay, there's one of them. And there's not just one, there is two of them. And with every triangle comes a base and a height, okay? And I want you to notice here that there is a right angle here. So it's kind of telling us that this whole thing here and this whole thing here represents the base of the triangle, even though it's rotated funny. Okay, so they even drew little lines like this to represent the height. So the base of this information that matters for area later is 12 and 12. And then the height of the triangle, 3.1. So I'm going to go ahead and take, I could draw it out like that, but 3.1, oops, 3.1 and 3.1. Okay, not the best, representation. If you want me to rotate it, like I can do that too, but I'm gonna leave it kind of based off what they give me, so far. Okay, so I'm gonna move on now. We have to notice how many more faces are here. So because there is a triangle, there's a side here, which means there's a rectangle there. There's this side here. There's another front one here. And then there's even a very background rectangle there. So we have 3 more shapes to draw, okay? I'm gonna pull out the highlighter and yeah, I'll switch to green, why not? I'm gonna go ahead and draw this one right here. See that little side, that little left side face right there. So I'm gonna go ahead and draw some green right here. And it looks, that is not the best. Okay, wait, try that again. Draw that out. And then I have to pay attention to the dimensions of this, okay? So because this is 12, this is also 12, and that's the side of it. So 12. And then notice the bottom is 4. So that is 4. Cool, done with that one. Gonna now move on to this face right here. I'll use a different color. Let's go ahead and use let's use red. So I'm talking about this one right here. And let me shade that in. Okay, and I'll do some erasing later, but I'm focusing on the red now. And so I need to draw that. I'll draw it here. Good enough. And then pay attention to the dimensions. So the length is 10. The height is 12. So 10, 12. Okay, almost done. I have one more face to draw. And it's the one that's in the very back. And to not confuse you with all the other highlighting I did, I'm going to go ahead and erase this highlighting. And why don't I kind of do this blue one. So what I'm referring to is this right here in the very back. Okay. All right. And then to draw that, I'll switch to some kind of blue. And it's another rectangle. Cool, good enough. And then the dimensions, right? Looks like the height of it is 12 and the length is 12, which is nice. It's nice to have numbers that are the same. So 12 by 12. Cool, I've officially drawn all the surfaces. And then just like the problem before, my next step is now to find the area of each one. I can start with these triangles. Remember, triangles are gonna be base, it's like base times height divided by 2. So I'm gonna go ahead and take 12 times 3.1 divided by 2. And so the area here is 18.6. And if that's 18.6, this is 18.6. Done with the triangles. Gonna move on to the green 12 by 4. 12 times 4, the area covered there is 48. Moving on to the red 12 by 10, that's 120. And then I'm moving on to the 12 by 12, which is 144. Cool, found all the area of the surfaces. Total surface area, I need to now take all these areas and add them up, right? Plus, plus, plus. And I'll write that in black over here. Surface area is 18.6 plus 18.6 plus 144 plus 120 plus 48. All right, cool. So my total surface area is 349.2. The units are yards, and because it's area, square units. That would be the whole thing there. All right, so I hope that's helpful for triangular prism. I'm gonna move on now to the next type of prism. What do we have left? We have 1, 2, 3, 4. So we have some pentagonal prisms, and then we'll finally do the surface area of a cylinder. So let's do this problem right here. Cool. These do take a lot more steps when you're dealing with the regular polygons that have more than 4 sides. For example, pentagon, hexagon, heptagon. So same process. Let's go ahead and deal and find the surface area of this. Highlight this pentagon at the bottom and the one at the top, so you know what I'm going to be drawing out. Drawing pentagons is kind of tough. Sure, let's do that. So there's 2 of those. And then let me get those dimensions, right? So when I'm looking at, maybe I can look at this top pentagon, right? The side is 7, so all the sides are 7. Same goes for the bottom one. I will have to draw a triangle later, so I'm talking about this here. That is 7, that is 7. And then, as I mentioned, we're gonna have to do those internal triangles. That's on both, right? This is what I'm drawing it on there too. The apothem or height for those, it is given to us. It is 4.8. So I'll go ahead and maybe like draw a little arrow and say that's 4.8. Same goes for the apothem here, 4.8. Cool. I'll do those calculations afterwards. So I'm gonna go back to my highlighter and focus on, there's a ton of rectangles here, right? Oh shoot, I didn't mean to do that. There's rectangles here. What's nice about, what's it called? Regular polygon prisms, right? We said that this is 7, this is 7, this is 7, this is 7. So the sides are always the same. And so because the sides are all the same, if we know the area of one rectangle or one of these sides, then we know it for all the ones around. So there are 5 sides, so there are 5 rectangles. I will still draw them all out for you for this problem, but in the future you can know to just find the area of one rectangle for this kind of problem and then multiply it by how many sides you have, which would be 5 in this situation. But I'll highlight regardless. So let's go ahead and take maybe blue, and then I'll go ahead and highlight this one right here. So I'll highlight that. I'll do it in blue. Cool. So let's do it. Yeah, let's do it on the side. I'm gonna draw one right here. And there are 5 of these, okay? So I will just kind of multiply these out, double up. So there's 4, and then I need 1 more because it's a pentagon. Cool. So there's the entire like net. That's all of it broken up, right? I took the top and the bottom. That's these 2 pentagons here. And then this rectangle, there are equally 5 of them. I do need the dimensions though, so let's zoom in here. Looks like the height all around is 9. So 9, 9, 9, 9, and 9. And then I need the width, or that, that side length, which we actually found out earlier. It is 7, right? 7 all around. 7, 7, 7, 7, 7. Cool. All right, so why don't we actually find the area of these rectangles first? That's a lot easier, right? I could just do length times width, and that's just 7 times 9, which I'm pretty sure is 63. So 63, and these are all the same, so that's really nice to get out of the way. And so now I just need to find the area of one of these pentagons. And when I have one of them, then I'll also have the other one, right? We're doubling up. And so let's focus on this one right here. I need to find first that little mini triangle. There are technically 5 of them, but I'm just gonna focus on one. Area of a triangle is base times height divided by 2. So I'll do that math down here for you. So base times height divided by 2. 7 times 4.8 divided by 2. Looks like 16.8 is the area of this, but there are 5 total triangles, so I'm taking 16.8 and multiplying it by those 5 other triangles to get the actual full area of this whole pentagon. So times 5, 84 is the area. So 84, let's circle that, and if that pentagon's 84, the one over here is also 84. All right, sweet. I now have the areas of all the surfaces of this prism right here. My last step is to add them all up. Add them all up. Wow, I can't talk. Add them all up. So surface area, let's do all this math. 84 plus 84 plus, I'm just gonna do 63 times 5. I'm gonna skip ahead. 63 times 5 plus 84 plus 84. There we go. All right, total surface area is 483. The units are in yards. Because it's area, it is in squared units. All right, cool. All right, you may look at this problem and try it out. Let me know if you need the link for this full sheet, but we're gonna move on now to our final 3D figure or solid, and that's gonna be cylinder. And so let's go ahead and look at the cylinder here. We're still doing the same process, right? Finding surface area requires you to find, find the area of everything that you have. So let's go ahead and start with highlighting the bases, which are circles. Go, that's the bottom. And here's the top. So let's go ahead and draw 2 circles that are identical, because they are identical. Cool. And then I'm going to take the info they give me. So they're giving me radii 11 and 11. Cool. And then now I'm going to focus on, you're going to see how this works when it comes to cylinders, all right? So you might be like, okay, yeah, we get the side, right? We get the side, but it goes all the way around. So this is how I want you to think about it. If you have, for example, a piece of paper with you and you roll it up, when you roll it up, it becomes a tube or it becomes a cylinder, right? And so if you look at the edge of this entire circle, aka the circumference, and then it attaches to this height, and then it attaches to also the circumference down here. That is what we are about to draw. We're basically taking this cylinder and we're rolling it back out into a poster. You can think about it that too, right? When you have a poster, it comes rolled up as a cylinder, and when you roll it out, it becomes a flat, rectangular, usually, surface. And so I'll use a different color. You know, I guess I'll kind of like erase this, and maybe I'll use like green. So what I'm talking about is, notice that I'm not gonna highlight the inside of the circles. What I'm talking about is the edge, the sides of this entire thing. Yeah, it'll look kind of funny how I do it. But I'm technically ignoring the inside areas of the circle. So let me roll this out, right? Like I said, it's like rolling out a mat, is me rolling it out like so, right? So this, you can take this all, and if you roll it up, it becomes, you know, it becomes the actual cylinder without the stuff on the inside. And so let's focus on what dimensions we could get from this first. So here, this is the same as the height of the cylinder, which we are given, which is 7. So I can nicely put 7 there. That's 7. And then now you might ask yourself, like, how am I supposed to get this length? Like, I don't see a number here. But remember, this at the top, for example, this length represents all of this. It's just rolled up into a circle, right? And we know the edge, right, the outside perimeter of a circle to be the circumference, right? It's at the top, and there's a circumference also at the bottom, right, which would represent this down here. And so this is where you need to remember the formula for circumference, which is 2, right, C for circumference, it's 2 pi r, okay? R being radius. We have radius, don't we? It is 11. And so for now, I'm just going to write 2 pi, and then our radius is 11. Okay, that's where I'm getting that from. And then I'll have enough info to find that area right there. Another thing is remembering how to find the area of a circle, because we need to find it for 2 of them, right? And as a reminder, area of a circle is pi r squared. Okay, pi times r squared. And so we can technically start doing the math for this. So I'm going to find the area of one of these, pi r squared. So that's pi times the radius, which was given to me, which is 11 squared. So that is going to be, I'm going to leave it in pi form, okay? It's going to be 121 pi. And if that's 121 pi, then the other circle is also 121 pi. So that's the area for this circle. That's the area for this surface of a circle. Last thing is that rectangle that rolls up, 7 times 2 pi 11. So I'm going to take 11 times 2 first, which is 22. And I'm going to multiply 22 with 7. 22 times, oh my gosh, 22 times 7 is going to give me 154. And then I'm just taking the pi and I'm putting next to it, keeping them together, okay? So last thing I can do now is take these and I can add them up to find the surface area, okay? I'll leave it in pi. Okay, so 121 plus 121 plus 154. All right, so 396 pi. And then I'm just going to double check that I did write the decimal version of this. And sorry for writing this in purple, but this is what I'm referring to as the surface area of the cylinder. But I'm just going to double check. 121 pi plus 121 pi plus 154 pi. All right, cool. Yeah, so either your answer is 396 pi if you leave it in pi form, or if you want to hit enter again and have the full decimal out, it's going to be 1244 point, let's do 071. The units are still centimeters squared because it's area, centimeters squared. That's your answers there. Here's all the work for that. I hope that's helpful. One last thing I guess I want to mention for, actually, no, I think that's good. So those are the examples on how we found surface area on all of these. So we did work through rectangular prisms, which you'll see, triangular prisms, how we draw all the surfaces for every type. We went through a pentagonal prism. You can do the same process for any type of regular polygon, and then we finally did the cylinder. If you have any more questions, just reach out to me, let me know, but I hope this was all helpful.